Okay, on these functions at the top of page 7, and by functions I mean equations. Six families that we just talked about in this order. So the first three are linear, quadratic, cubic. How do I know that? Because there's just an x here, there's a squared here, there's a cubed here. Then the next three are the absolute value, the root, and the exponential. So we have the absolute value lines here, the root here, and look where your x is. It's up here in the exponent position. So we have the symbols for the 6 different families. And then mixed in with those symbols are all the different things we can do to that parent function to make it look different. And it literally is every single thing that you can do. So this one, just to be clear, and you don't have to write this down if you don't want to, this parent is y equals x. And for this one, the parent is y equals absolute value x. And then all those letters around it are things that you can do to change what y equals x looks like. So there's 4 of them. Hopefully you're noticing that there's 4 different things in each of these equations. There's a negative on the front of all of them. There's the letter A on all of them. There's the negative h and the plus k. So I'm going to run through what each of these things does, and then we will see where we're at. So I'm going to kind of color code it with my pens. You're welcome to do whatever works best for you. So the first thing that we have are these negative symbols. For each one of these functions, if you have a negative on the front, it takes your graph and flips it upside down. So I'm just going to draw a little arrow and say, this is going to reflect my graph. So whether it's a line or a parabola or a roller coaster, if you put a negative on the front, it is going to flip your parent function over across the x-axis. So while you're labeling that, if I can quickly, because I don't want you waiting forever, I will go to Desmos and show you on a couple. So just give me like 30 seconds and then stop it. Not you guys, this thing. Okay, if you want to see what this looks like in Desmos, you can look at the Windows side. So the first one that we have is the line y equals x. So if I put a negative on that, it's going to flip it over the x-axis. I'm not going to leave the parent there. I'm just going to put a negative on so you're not watching this forever. So if I put a negative on the line, it flips it the other direction. So if I take it off, it's going positive. If I put it on, it flips it negative. For the parabola, it's going to flip it so that it looks like a frowny. So it's going to go from a smiley, let me move it over, to a frowny. If we do it for the roller coaster, so he starts, this is the original, he starts on the negative side and moves over to the positive side. If you flip him, it's backwards. For the root, it's going to, instead of being on top of the x-axis, it's going to go underneath the x-axis. So it flips it over. Is that making sense? Yes, no? And then the absolute value, it takes it from a V to like a triangle. So I'll flip this guy. And then our last guy is the exponential. So it flips it down. Instead of going up, it goes down. So if you put a negative on, it's going to flip it upside down. So then our next one, and you don't have to do all 4 things, but if you have a negative on the front, that means you flipped it. If you have a number on the front, so this represents a number. The letter A represents a number. If you put a number on the front, this is going to change your size of your graph, and what we usually call it is a stretch or a shrink. So if you put a number on, and it doesn't have to have a negative, we could just have 8x squared and nothing else. It's either going to stretch or shrink the graph. It is a stretch if your number is bigger than 1. So if it's like 5 or 8 or even like -7, so maybe bigger than 1's a bit of a misnomer, but or 2, that's going to stretch your graph. If it's a 1/2 or a 1/3 or like a 1/5 or a 2/5 or a 3/5, it's going to shrink your graph. So I remember this one by thinking, okay, a fraction is small, so fraction means shrink, a bigger number means stretch. Are you hanging in? Yes, no? Was that a yes? I don't know. Okay, the third one is the one that causes the most trouble. So the first thing that I want you to notice is these negatives. This negative means that whatever you have written down with the X, tracked with the X, means you have to do the opposite of what you see. That negative means if you see a +5, that means you moved your graph -5. If you see a -2, that means you moved your graph +2 because of this stupid negative here in with the symbols. So when I highlight this guy, I'm just going to do my best to make any kind of note that I think might help me to remember that if I have something trapped with the X, that's going to be a left or right shift, and I have to move the opposite of what is written. And I'll go a little bit more in depth with that after we finish the last one. So I don't want to be lecturing for much longer. And then for me, this last one is the easiest one. This +k. It's not the y-intercept, but it does move your graph on the y-axis. Well, so yes, sometimes it is the y-intercept, but not always. So this is going to shift your graph up or down. If you see a +5, that means it's going up. If you see a -5, that means it's going down. There is no trick to this one. The only trick is that one that is trapped with the X. So one helpful thing may be to show you very explicitly what I mean when I say trapped with the X. So in about 10 seconds, I'm going to give you an example of what I mean by that, which means I'm going to cover up the screen. Okay, when you hear me say it's trapped with the X, I want you to look at these two absolute, and by absolute I mean square root functions, and decide which one in your mind looks like it's trapped in with the X. Is it the top or the bottom? The top. So when I say trapped with the X, I literally mean whatever symbols you have, it's in the symbols with the X. So this guy would be a right 3. But teacher, it says negative there. I know, but when it's trapped with the x, you got to use the opposite. So this would mean right 3. This means down 3. I think I'm going to write this here on page 6. So this does not match these notes. I am just going to write these for us as examples. So I'm going to use that one I just wrote down. And then you'll do some whiteboard. We'll be done. I wanted that to be a minus. Okay, so the top one, make sure that you understand that because it's trapped with the x, you're not going left -3, you're going right 3. But because this one is not trapped with the x, that means that you took the root function and moved it down 3. So if the number is written in with the x, that means you move it on the x-axis left or right, but you have to do the opposite. If it's not trapped with the x, it's an up-down, and it's exactly what you see. So let me give you another example of one being trapped and one not being trapped. Y equals x squared plus 5, and y equals x plus 5 squared. On one of these, the 5 is trapped in with the x. Is it the top or the bottom? The bottom. So in this case, in my mind, this 5 is trapped in with this x. So this means that we went left 5, because you have to do the opposite of what you see. But this one means you went up 5. That is a lot to keep track of, especially when you add in a reflection, or you want to make it bigger, or you want to pull it up so that it's more narrow. Do you want another example of one trapped and one not? Or are you feeling kind of okay? I'll show you I did one for you guys and you were like, whoa, I'll show you that one. And then we'll do some whiteboards. So this guy is an absolute value where he has one trapped and one not trapped. So this is left or right. Which direction did we go? Did we go left 2 or right 2? Left. So this matches a left 2. And now this, because it's not trapped, would be a down 3. Do you guys remember seeing this at all last year? I know that it's a lot at once. So I told you what's on this does not match what's on this page. So I'm just going to really briefly show you what is on this page. Like, I'm not even going to talk about it for this long. This is the reflection. So what we were supposed to do here was say, okay, we recognize that a reflection is where you flip the graph. So this guy would be y equals the root of x. And this guy is equal to y equals the negative root of x. And they're trying to get you to recognize that you took that root function and flipped it over. Like you literally reflected or flipped your graph. So they're trying to get you to recognize that if you put the negative on the front, it flips your graph over. The next one is showing you what a stretch and a shrink looks like, but he's kind of weird. So this one is your size change. And the parent that they give you is y equals x squared. And they're trying to show you to the right that they're changing its size. So in my mind, this one looks bigger or wider. This one looks smaller or more narrow. Unfortunately, this is another stupid opposites one. So turns out that this guy is y equals 1/4 x squared, and this guy is equal to 4x squared. So the shrink actually makes the graph look wider. I know that that seems weird, because it is weird. So this guy is your shrink. This guy is your stretch. You normally say shrink by 1/4, stretch by 4. And you'll have your notes to refer to, so you don't have to memorize any of this. You just need to know how to match what you're seeing up with one of these examples. And then we don't have to write anything on the third one because these are your shifts. This is explaining right here what's happening in these pictures. So if you wanted to write these down, you can, but you absolutely do not have to. I will just write them for us really quick. The parent for this guy is the cubic family. So y equals x cubed. I'm just looking for my pen really quick. Maybe I'll use my pencil. So this is your parent. This means we shifted up. So if you look at this graph compared to this graph, they're saying you took this parent and shifted him up 5. So he looks like x cubed plus 5. And this one has been shifted down 1. So he looks like x cubed minus 1. Notice not trapped with the x. The next two have been shifted left and right. So we have to trap it with the x. So on this one, we moved it left 2, which means on our paper, we have to write plus 2 in with the x. So this one is in, this one is out. Inside with the x, out of the x. This one got shifted to positive 5, which means we write down on our paper negative 5. So this is the one where we use opposites. The blanks don't really match there. But this is the one where you use the opposite of what you see. And then these were our examples of being inside with the x or outside with the x. So to end the day, let's just do a few whiteboard questions and be done. Green whiteboard. No quiz today, no worksheet. We'll do it next time. Yes, but leave it out until we finish our whiteboard questions, because you might want to refer to it. Okay, for these first few, only one thing has been done. You tell me what's been done. So, on this first one, I'm just going to tell you. On your whiteboard, you would write shrink by 1/3. I'm just trying to get my dog viewer to zoom out as usual. So on your whiteboard for this one, you would write shrink by 1/3. Is that making sense? If my dog viewer will ever zoom out. There we go. Okay, so on this one, write down what I did. Oh, yes, I thought it was 5. Did I write 5? Thank you. About 10? Yes, you write out like what happened to it. Five, 3, 2. Okay, what one thing did I do to this cubic function? We reflected it. If there is a negative on the front, right here, that means you reflected. A negative does not mean shrink. Shrink is a fraction. It has nothing to do with a negative. See, this is what happened on my A days. Okay, this guy, I did one thing to this cubic family. What did I do? I either reflected it, stretch or shrink, or moved it left, right, up, down. Ten. 5, 3, 2. Okay, show me and hold it up for a minute so I can verify who's participating. This is a left 1. What is the one thing that I did to that guy? Ten. 5, 3, 2. Okay, show me what you're thinking. This is a stretch by 8. Stretch by 8. Okay, what is the one thing that I did to this x squared function? This is the parabola family. X squared, what did I do to this guy? Ten. 5. Okay, show me what you're thinking. This is an up 5. This is not trapped with the x. This is what it looks like if you went left 5. Down here. Okay, this thing has had 2 things done to it. What 2 things happened to this absolute value? I appreciate those of you that are trying and looking in your notes. Or just trying. That's awesome. Two things have been done. Five. 3, 2. Okay, let's see. Shrink by 1/5 and up 2. Let's do 2 more and then be done. Okay, this has had 2 things happen to it. We have 1 more after this and then we're done. Ten. 5. Okay, show me. This has been reflected and shifted left by 3. This is trapped in with the x. Okay, our last one is kind of a challenge. This is the exponential family. So this started out as y equals 2 to the x. What did I do to y equals 2 to the x? About 10. Five, 3, 2. Okay, show me what you're thinking. Leave it up for a minute. This is a shrink by 1/2 and a right 3. So this is trapped with the x. It's up in the exponent with the x. Okay, we'll start on this again next time.